Okay, so this video is going to be more of a prep video for the videos that are going to be coming for this upcoming chapter. So this entire little chapter is going to be measurement and geometry. So here we're just going to do a quick review of some things that you should probably already know before we dive into the stuff. For example, things like perimeter, like I don't know how to explain. Well, yeah, the distance around an object. So if you have a rectangle that's 5.6 on one side, 8.2 centimeters, then your perimeter is like length plus width times 2, or 2 length plus 2 width if you want to expand using the associative, not distributive property. So you would have 8.2 plus 5.6. And that's 13.8. And that is kind of went curved there. But let's say when it comes to a circle, the radius is from the middle to the end. Let's say we have a radius of 5.3. 5.3. And just for educational purposes, from one end to the other end, going through the middle, is the diameter. And the diameter is 2 times the radius. So just remember that. So let's look at the perimeter of a circle, which is called circumference. I had to check the spelling for a second. So circumference, we know, is 2 pi times r, the radius. And everybody knows pi is that glorious number. So we have 3 times 3. Sorry, I'm still sleeping. Yeah, I'm still solving this question right here, where the radius is a 5.3. So we get approximately 33.3. And when you want to put approximately, you kind of just put a dot there, or you could like do this. C equals approximately. Yeah, that is that. Let's just go over upside down, you could like piece it into there. That's why it's base times height over 2, because you have the height and then the base over 2 is this. So it's kind of like finding the area of a rectangle. Kind of interesting. Moving on, let's go with a circle. And remember, radius is from the middle to the end. So if you're given a diameter, divide that by 2 and then plug it into the area formula for a circle, which you'll have good old pi times r squared. And yeah, that is that. Let's go over a couple more shapes before. I don't even know before what. But yeah, let's do my horrible parallelogram. Let's try again. Nope. Yep. I don't know. Let's go like that. Like that. Let's call this the base. And let's call this the height. And the area for a parallelogram is base times height. And again, this is because, remember, these angles are the same, and these angles are the same. And if I was to cut this side over here and just paste it on this side over here, you would again have lo and behold, a rectangle. That's why it's a base times height over 2. Let's go over one more tricky one. Let's do everyone's favorite trapezoid. Ignore that. Let's say at the top is A. Let's say at the bottom is B. Let's say the height is H. So now you have this formula where it is the area of a trapezoid is A plus B in brackets times height over 2 or 1 over 2 H A plus B. And this one is also derived from having these two triangles. So if you were actually to sit down and like do the math, you basically have I mean, it's a very long process to do, but like kind of odd to visualize. You never really are going to need to know this, but it's just interesting. If you were to subtract B from A, like this whole in middle part right here, if you do height times A, you get the area over here. But then what about this area over here? trapezoid's formula, you could easily get that just from subtracting. In this case over here, on the trapezoid side, subtract these two, b minus a, and you multiply that by the height. So, if you were to do a times b plus b minus a times h, and simplify this formula, you would actually end up right over here. But that kind of math is not what we're doing today, and we're not going to need to know that right now. So let's look at another thing that we're going to need very quickly. And this one is just volume. Let's picture this as a rectangular prism, or rectangular prism. Let's say this is 3 times 2 and the height is 4. The volume of this is just length times width times height. Very simple stuff. 3 times 2 is 6 times 4 is 24. Yeah, if this was in meters, then you would have meters cubed. Remember, the units always matter. If you had a triangular prism, let's say you had the base and a height. So you had a height of, let's say, 10, and then a base of 10, and then that's not 2. Let's say you had a length of 20. This is also similar to its previous one. You take the volume is basically the area of the base times height over 2 times again, very simple stuff. Base times height over 2 times length. Another one that is going to be very tricky is the cylinder. Remember, cylinder's surface area is basically, if you were to rip open a can, you would have a circle on the top, and if you were flat out the middle part, it'd be a rectangle. And then again with this, so for, let's say, let me get some space. the circumference of the circle, the amount, or the distance around the circle, that's going to be the length of this rectangle. So remember, the formula for circumference is 2 pi r, and that's going to equal the length here. But if I want length times width for the rectangle's area, I gotta multiply it by the height. And that's why the surface area of a cylinder is 2 pi r squared, which is 2 times the area of a circle. This one and this one, plus 2 pi r h. H is just the length, and the width is the circumference of the circle that is connecting it. Yeah, very simple stuff. And as we know that pi r squared is the formula for the area of a circle, if we multiply the area of a circle times the height of the cylinder, that'll give us the volume of the entire thing. So yeah, very, very fun stuff. Let's see how we put all this into use in the upcoming videos. So yeah, see you in the next one. Okay, so in this video, we're going to do everybody's all-time favorite thing, Pythagorean Theorem. So yeah, this was named after a Greek philosopher and mathematician, Pythagoras. And he basically used a formula to he came up with a formula that applies, discovered the formula that applies to all triangles. All right triangles. So right being, I messed that one up. Meaning it has one angle that has 90 degrees. So let's call this side AB and the sides C. So the two sides that adjoin to create the right angle here, the 90 degrees. Those are sides A and B, and C is what we call the hypotenuse. The longest side of a right triangle, the side opposite to the 90-degree angle. So yeah. And as most people watching this probably already know, that is the formula to calculate. Well, this is the formula, this is the relationship between the two sides and the hypotenuse. So, a lot of people are gonna ask, like, okay, or I've heard a lot of people ask, when are you ever going to use this? Let's say you had a TV, which was, one side was 22.5 inches, other side was 37.5 inches, and I was saying I wanted to know what the length through the middle is, which is the size of the screen. So let's call that D. This is a perfect application for the Pythagorean theorem. So we can say that these two sides a joint to make the 22. The A and the B, and we're looking for the C, so if we were to plug this in, 37.5 squared plus 22.5 squared equals D squared. Oh wait, I have messed that one up. Oh no, I have white on the screen now. That's okay. This is 30. 900 squared plus 506.25. My brain is just not working today. 900, not 900 squared. 30 squared is 900. 22.5 squared is 506.25, and that's equal to D squared. So we have 1406.25 equals D squared, and we take the square root out of both sides, and we have that's why I had 37 over here and there. Mistook my handwriting. That's okay. Let's try another one. Let's say you had a ladder leaning up against the wall. Hopefully a straight wall. And this is the ground. And the ladder, we know, is 4 meters long. And the wall, or like the base of the ladder, is 1.4 meters away from the wall. And now we want to find out how high up does the ladder reach on the wall. And this is another example of us using the Pythagorean Theorem. So we can plug in, we know that 1.4 meters and h are the two sides that come up to become the right angle, so we have 1.4 squared plus h squared equals 4 squared, because the hypotenuse in this case is the 4 meters, the length of the ladder. And if we were to start simplifying or solving, then we will eventually get to sailboat that has a flag that has a triangle flag on it. And let's say we want to find out the area on this. So now we could just do plug in our Pythagorean theorem here and just do we have the hypotenuse. Sorry, not area. Right now we want x squared. So we have, remember, for area we need the area of a triangle is base times base. Oh, come on. Base times height over 2. Well, here we have the height of 8 centimeters. We don't have the base. That's why we're looking for x. So if we were told to find the area here, it would be a two-part problem. One, finding the base. The second, plugging it in to find the area. So here we have 8 squared, because the x and the 8 are the ones that adjoin, or a squared plus b squared. So you have 121 equals x squared plus 64. And then you have, if you isolate the x squared, you have x squared equals 57, which if you square on both sides, it's about 7.5. And then yeah, you can basically plug that into here and see that it's 8 times 7.5 over 2 equals about 30. Yeah, 30 centimeters squared. So yeah, I hope that has changed your outlook on the Pythagorean theorem, and we can all learn to live together. And yeah, that's it for this video. I'll see you in the next one. Okay, so in this video we're going to be looking at perimeter and area of composite figures. So what I mean by this is basically we're going to be looking at how we can use our knowledge from previous videos to solve problems in this one. So in previous videos we looked at how we could basically find area and perimeter of various shapes like a triangle or a square, rectangle, circles, everything. So in this video we're going to basically apply what we've learned. So let's look at an example where I have a weird looking shape like this. Let's pretend that this is a 90-degree angle here, and the distance from here to here is 4 centimeters, and then the distance at the top from there to there is 24 centimeters. let's say that the height here is 16 centimeters, and then let's say that this is also a right angle triangle 90 degrees, and the distance from here to there is 12 centimeters. So now, let's say I ask to find the area of this shape. So now all we can do, as you've probably already seen, is break this down into 3 components: 1, 2, and 3. So basically, I can see that okay, the first and the third objects are triangles. So I'm going to basically use the area formula for a triangle. Base times height over 2, and in this case the first one is the base is 12 and the height is 16, and we divide those by 2. So we have that should be 96 triangle 1, and then triangle 3, part 3, the area of the third part, which is the second triangle. That one's also base times height divided by 2, and the base here is 4, and the height is still 16, and then we divide it by 2. That leaves us with 32. Again, these are area is cm squared, and then the middle part, number 2, that is the easiest of them all because that's simply a rectangle. So we can just do length times width. So 16 times 24 equals 384. That's the second area. Okay, so we have that, and yeah, now we just add A1 plus A2 plus A3, and we have 384 plus 96 plus 32, and we get a total of 512. Don't forget the units. Okay, so let's do the exact same shape, but now we're going to be looking for the perimeter. So the perimeter is of this object. What I'm asking for is like, the total, like the distance around the entire object, so of all the lengths of all the sides added up. So here, if we look at this object, we know that this one here is 24. We know that the bottom one is 24 plus 12 plus 4. That gives us this whole bottom one down here. So 24 plus 12 plus 4, that'll give us hold on, do some mental math. 24 plus 12 plus 4, that's 4, 4, 8, 10. That's a 40. Well, yep. Sometimes I have brain farts where I cannot do mental math on the fly, but then sometimes I can do some odd calculations in my head. Anyways, now let's look at the other two. So we know that the bottom one is 40, and we know the top one is 24. What about these sides? This one and that one. That one whole square is 144 plus 256 equals x squared, which these two add up to 400. And if we take the square root, that's 20. So we know that this side is equal to 20. Now let's look at this side and call it y. We do the same thing. We have 16, and then we have the 4. So we have y squared equals 4 squared plus 16 squared, which is 16 plus 256, which is 272. And if you take the square root of that, it's going to be approximately 16 point something something. But let's just take 16, and then now we have all the sides. Now if we add them up, if we add up all of the sides, now we have 20. And 16. Now if we add up all of them, we have 100. So, because this one's point something something something, I didn't really look into it. It's also approximately, or you can use that. That also is approximately. So yeah, that is that example. Let's look at one more. Okay, so in this example that I've drawn out here, so let's look at this. And let's say I want to find the area of this object here. Right off the bat, we see that I tell you that this is a semicircle cut out of a rectangle. Right off the bat, we know that we're going to use the length times width formula for the area of a rectangle and the area of a circle. So what we're going to do is calculate the area of this rectangle. 2.1 times 5.2, which is about 10.92. And that would be the area of this full rectangle. But what we can do now is basically subtract the area of this circle that is not here by using our semicircle, well, our circle formula. The area of a circle is pi r squared. That'll give us the area of the whole circle, but we want a semicircle, which is half of the circle. So we're going to do pi r squared over 2. And if we plug in our radius, right now we're given the diameter of 2.1. We see that on the other side, but the diameter is twice the radius, so we're going to use pi times the radius, which is half of that. And that is going to give us 1.73-ish. So if you take the area of the rectangle and subtract it by that, we're left with about 9.19 meters squared. 9.2 if you round to 1. Now the perimeter is kind of the same situation. We do have these two sides, 5.2, 5.2, and then we have this 2.1. But what about this right here, this line? Again, all we gotta do is take the perimeter formula, like the circumference of a circle, and divide it by 2. And the circumference is pi times d. And for a semicircle, we divide that by 2. And we're left with pi times 2.1 divided by 2. We're left with 3.3. And if you add that with this, you get 15.8 meters. is all for this video in perimeter and area of composite figures. I will see you in the next one. Okay, so in this video we're going to look at surface area and volume of prisms and pyramids. So by definition, surface area is the number of square units needed to cover the surface of a three-dimensional object, and the volume is the amount of space that an object occupies measured in cubic units. And then let's move to prisms. A pyramid. So a pyramid is a polyhedron whose base is a polygon and whose faces are triangles that meet at a common point. So a pyramid does not necessarily only have a square base, even though that's what we most commonly think about when we hear pyramid. A pyramid can also have a triangle for a base or a hexagon. But yeah, let's see that in this video we're going to mainly focus on surface area and volume of pyramids per se. So let's look at a pyramid, and I'm going to try to draw one here. Oh no. And then let's say that that's in the back. So we see that in this case we have a square base pyramid, and a square base pyramid has, well, exactly that, a square base. So it's going to have a square base, and then it's going to have a triangle on each side. If you picture me opening up this pyramid, pretend this is a piece of paper, and we do the origami and fold all the sides up, and all these, this corner here, that one, and that one, they all meet up at the top. So when you look at a square base pyramid, you are really looking at a square and four triangles. So when we talk about the surface area, it's fairly simple. You have the base, the area of the base, and then you add the area of each triangle, but there's four of them, so we're gonna do for a triangle. So if in this case, let's say the one side of the pyramid ran up. Well, no, you can't use that. Let's say I was given this middle length here. If you look at a big pyramid, let's say I was given the length of this middle part right here. Then I could use, because this would be my height, and then the measurement this way would be my base that allows us to use the formula for a triangle, BH over 2, base times height over 2. Now for the square, if you're given one side to be, let's say, this middle length here, let's say that is given to be 27.8 meters, and then that's the height of the triangle, and then I'm given a base of 35 meters. So when I'm given a base of 35, the square rectangle is going to have, the square base is going to have 35, 35, 35, and 35 on each side. So we can just find the area of that by doing a simple length times width, 35 times 35. But then here we have the 4 times the base times height over 2. So if we were to plug in these two numbers over here, then we would end up with the length and the width of the square are 35 each. 35 each, and then we have 4 times the base, which is 35 still, and the height of 27.8 divided by 2. And if we do a little bit of mental math, we end up with a total of 3171. I didn't do mental math, I actually have it written here. Yeah. So now that that was basically how easy it is to find surface area of a pyramid. Let's look at volume now. So, let's say I have another square base pyramid where I'm given the height of the triangular side as 10, and then the base I'm given 8 centimeters. So when we look at the volume of the pyramid, we can use this formula. Volume equals area of the base times the height, all times 1/3. So, how can we solve for this? Let's just say that in this particular case, so one thing we're gonna have to do here is visualize the height here. When it says height, it's not referring to the length of one of the sides, it's referring to if you were to flatten out the pyramid dead center of the pyramid to the top point. So from here, this is the midpoint. So that's an entirely different measurement. So here we can easily compute that. If you look at the pyramid from a side angle, we know that one side is 10. Sorry. The base side is 8 centimeters. And then we have our triangle, like we're looking at it from one of the sides. And we know that the length running through this is 10. And we want to find this, the height from the dead center going straight up. And that we can easily find by using our good old Pythagorean Theorem, where we have our hypotenuse as 10, and then we have, let's say I want to call it x, but I can't see it. Anyways, x squared plus 8 squared equals 10 squared, which is x squared equals 100 minus 64. Oh, sorry. My mistake. It is not 8 squared, it is 4 squared. Because if I draw it even bigger, 8 is the distance from this to that. But I want half for this triangle, so it's 4 on this side, 4 on that side. I'm getting old. So x equals 100 minus 16, which is the square root of 84, which is about 9.2-ish. So we have 9.2 as the height. So if I was to put this in now, and the area of the base is still, by area it means surface area, we still have an 8 by 8 square at the bottom. So the area is basically length times width, so that's 8 squared times 1 over 3. So now we end up with about 196 point something. But yeah, since we're working centimeters, we're gonna use centimeter cubed. Yep, we did it. So that's all for this one. Actually, let's do one more. I know I hated it when the teacher used to do that to me, but now I'm gonna do it to you. Let's look at something very quickly. It's let's picture a triangular prism. Let's say we have a triangular prism, and this is equal to 3 centimeters. This length is equal to 3 centimeters. Basically, we have an equilateral triangle here, 3 centimeters. Even this side here, over here, that's also 3 centimeters. And then we have 12 centimeters for how long this is. And I wanted to find the surface area. The surface area here is fairly simple. We use the same trick to find the height of this triangle. We know that this is 3, this is 3, and this is 3. So the triangle we use for our Pythagorean is going to be 1.5 and 3, and then solve for x. And we just plug that in, and we get 9 minus 2.25 equals 6.6, 6.75. The square root of that is about 2.6. I'll put this. So now we know that this triangle has this triangular prism has 3 rectangles, each 3 centimeters by 12 centimeters. So the surface area is equal to 3 times the surface area of the rectangles plus 2 times the area of the triangles. So now we're left with the area of the triangle. That's not area. The area of the rectangle. So we're left with, we know that 3 times 12 is the area of the thing, and we have 3 of them. And then we have 2 triangles. So 2 times, let's say the base times height, base of. So we have the triangle like this. So this is 2.6, and then this length like that is 3. So we're left with, so 2 times the base is 3 times height divided by 2. And now we could just start working our way into this. 3 times 3 is 9. 9 times 12 is 108. And then we have 2 over 2 is 1. So it's just 3 times 2.6, which is 2, 4, 6, 7.8. And that gives us about 115.8 centimeters squared. Okay, we're gonna do the volume for this too very quickly, which is much easier. The volume for this prism is basically the base, which is a triangle, times the height. So the surface area of the triangle times the height. And we know that the area of the triangle is 2.6. Area of the base is 2.6 times 3 over 2 times the height, which is 12. So that leaves us at about 46.8 centimeters cubed. So yeah, that's how easy it is to do surface area and volume of pyramids, prisms, triangular prisms. So yeah, that's how easy it is to do surface area and volume of prisms, pyramids. I hope you enjoyed this one. I shall see you in the next one. Okay, so in this video, we're going to be looking at the surface area of a It's not the best looking one, so let's do. So yeah, let's just take a quick look at some of the key terms that I'm going to be referring to here. That is going to be referred to as the height of the cone from the dead center of the circle to the top, which is the vertex, and from the vertex to the edge. This is called the slant height, and the face at the bottom, like the entire circle, that's going to be called the base. And from the middle to the edge, that is called the radius. So let's look at how we're going to find the surface area of a cone, like we've done other objects and shapes in the previous videos, but this one's a little tricky, or just the understanding of it is a little tricky. You can always just memorize the formula for the surface area of a cone. And yeah, so obviously we have a circle at the bottom here. So when you are looking for the surface area of a cone, you are going to, that's one part of it, the area of a circle. We all remember area of a circle is pi r squared. Yeah, it should be pi r squared. But now we also need the formula, or like a way to calculate this part right here, this circular weird part that's small at the top and big at the bottom. We need a way to calculate this. So if you can picture it, or not even picture it, just if we look at like this slanted area, we refer to it as the lateral area of the cone, the part, the side, referring to the side area of the cone, the lateral area. So like this area right here, going all around. So the lateral area that is what we're looking for, and the way we can reason to find a formula to calculate this is by using ratios. So if we look at the circumference, that's horribly written, sorry, of a cone, and divide that by the circum of a circle. The ratio of area is going to be the exact same. This might be a tough concept to wrap your head around, but yeah, basically the ratio that the area of the lateral area of a cone has to the area of a circle is the same ratio that the circumference of a cone has to the circumference of a circle. So basically use this logic or this ratio. We could basically just plug in that the circumference of a cone is 2 pi r, and the circumference of a circle is 2 pi, let's say, I want to say s, let's use slant height. If we were to basically draw it, it would be like from there, and then the radius here is going to be r, and then we have the area of a circle. It's pi s squared over the area of the lateral. Now, if we were to simplify this ratio, we have 2 pi cancels out, and we're left with r over s equals lateral area over pi over pi times lateral area over pi s squared. And when we simplify this, we're left with r over s times pi s squared, which is pi rs. I mean, no one's really ever going to ask you to find or like derive this. I did it for fun because I'm a little weird, but if you just remember that the lateral area of the lateral area is equal to pi rs, s being the slant height, r being the radius of the base, and then that's exactly how we will find the total surface area of, that's the circle, and then we have pi rs. So yeah, this is now the formula of our cone. So let's try to do an example. Let's just say we had let's say we had a height of 8 and a radius of 3, and I didn't know what the slant height was, and I wanted to find the surface area, but we absolutely need the slant height. And again, as we learned earlier, easily we could find in one of the previous videos we used the Pythagorean Theorem to find that out. So in this case, if we look at the cone from the side, a side view, we have 8 here, we have a radius of 3, and we want to find this. So basically, we could easily do 8 squared plus 3 squared equals s squared, which is 64 plus 9 s squared equals 73, now we have the radius and the slant height, so we can just plug in 3 pi times 3 times 8.5. And that'll give us about 100 approximately 108. And since we were using centimeters, we're gonna be using cm squared. So yes, that's all I got for this video about the surface area of a cone. I shall see you in the next one. Okay, so in this video we're going to be looking at the volume of a cone. So in the last one we did a bunch of derivations to find out why the surface area formula is what it is, but I'm not going to do that in this one. This one I'll flat out tell you that the volume of a cone is equal to 1/3 of the volume of a cylinder. Now, what does this mean? So, everyone knows that a cone is shaped like that, right? You guys know that, right? Okay. And a cylinder is shaped like that, more or less. So, let's imagine that these two cylinders have the exact same radius of r, and the height from the cone is at the dead center here, all the way to the top, to the vertex, and the height of this is here. Height, and let's say these both have the same height. If you were to, the volume of a cylinder is basically the surface area of the circle times the height. But if you were to keep the exact same base and turn that into the same base, same radius, same height, and just convert it into a cone, just shave off the tops like this, like just start shaving it off like that, all around, and turning it into this cone. Basically, you'd be left with 1/3 of your original if you started right here and if you kept the vertex right at the top. That's why we have it to be 1/3. I know I said I wasn't going to explain how we get the formula, but I just proceeded to explain anyways. But let's look at it. Let's say we have a height of 12 and a radius of 4. There really isn't much to do here other than like just plug and play. So 1/3 times the volume of a cylinder, that if you all remember, it's the surface area of the circle times the height. So the area of the circle is pi r squared and then times the height, but then 1/3 of that, that's the volume of the cone, so we're gonna plug it in, pi times 4, that's our radius squared, and then we have 12 divided by 3. So yeah, that gives us about, if you punch it into a calculator, 201 point something something, but remember we're using cm. Remember the units, cm cubed. Never forget the units. We need the units. So let's do one more, but with a little different. Okay, so let's say I have this. I apologize for my bad drawing. Let's say I have a diameter of the circle at the bottom to be 10 centimeters and a slant height of 8. And then I ask for the volume of the cone right off the bat. I have this formula, but what do I do with it? Since I need the radius, which is, I have the diameter, so you know, r is equal to d over 2. I have that, that's 5. But the height, what do I do with the height? And you guessed it, we're going to use the good old Pythagorean Theorem. That's a 90-degree angle, or semaphore. So we have we have the radius 5. So it's like, we have the 8, we have the 5, we need this height. So that is going to be, you guessed it, h squared plus 5 squared equals 8 squared. So h squared equals to 64 minus 25, which is 39, and then if you take the square root, that's about 6.2. Yeah, 6.2. And lo and behold, I'm just going to plug these numbers into a calculator. Why? Because I can. It's about 162. There's something, but I'm gonna say centimeter cubed. Never forget the units. The units are important. So yeah, that has been the volume of a cone. That is the end of this video. I shall see you in the next one. Okay, so in this video we're going to look at spheres, and I'm sure you know what a sphere is. 3-dimensional shape, a round ball-shaped object let's continue on this series of finding, let's do surface area. So the surface area. The surface area of a sphere is 4 pi r squared. The logic behind this formula is that pi r squared is the area of a circle. So when you have 4 circles and you stitch them together on the edges, you can basically shape a sphere. So let's look at an example. Let's say we have a ball or a marble that has a diameter. A diameter is from one end to the other end. Let's say the diameter is 2.5 centimeters. And I want to find the surface area of this specific marble. So, as we all know, radius is half of the diameter, or diameter is 2 times the radius. But yeah, in this case r is 1.25. So yeah, there we have the radius, and then the surface area is honestly just plug and play. So 1.25 squared times pi times 4, we get approximately 19.6. And yeah, we're using centimeters, so surface area, we should have centimeters times centimeters, centimeters squared. So yeah, spheres are very easy, very straightforward. Not like the cones and the cylinders and those type of things. Let's look at another one. Let's look at, say we had a baseball that was like, that's my best attempt at drawing a baseball. So, again, let's say the surface area of this baseball was 215 centimeters squared. Let's say I knew that and I gave that to you and said, hey, there is a baseball with this kind of surface area. I need you to give me the radius of this baseball. So, because we're handy, we just go, okay, according to this formula, I already have it written up there. I can just do 215 equals 4 divided. Well, I'm looking for the radius. So r squared is what I want to isolate for. So if I divide both sides by 4 pi, I'm left with, yeah, r squared on this side because the 4 pi and 4 pi cancel out, so I'm left with, and then 4 pi, if I take the square root of each side, I'm left with r sometimes I forget, but that's okay. I'm done school. So yeah, that is the surface area. Very straightforward. I think now we can look at the next big thing about spheres, which is, yeah, you guessed it, the volume of a sphere. So let's look at a sphere. So the formula for a sphere comes from, in one of the earlier videos we figured out how we got the volume of a cone by saying that it's a percentage of a cylinder. So basically we did like so we said that okay, the bottom was going to be the same, and then if we pictured that from the dead center of the top, we carved out a cone that would be 1/3 of the volume of the cylinder that we originally had, with a height and a radius. So that would give us the cone. Now we're gonna do something quite similar. With the same kind of logic, we're going to take the volume of a cylinder and say that it is a certain amount of the sphere. Sorry, the sphere is a certain amount of the cylinder. So picture a cylinder, take a cylinder with a certain height, let's say h, and let's say you carved it out without making it shorter, the same height. You made a sphere with the same radius as this r. This is supposed to be, I can't spell. That's supposed to be a sphere. So yeah, picture that you carved out a sphere or like a ball from the cylinder, and by that logic, the volume of a sphere is 2/3 the volume of a cylinder of the same height and radius. So we know that the volume of a cylinder is the surface area of the circle on its face times the height, which is that. So the surface area of the circle is pi r squared times h, which is the height. But one thing that we are going to remember in this case, because a sphere is perfectly round, so that the height has to be exactly the same on all sides, so going like this way to that way. But we know that half of that is the radius, so we can just say that the height is equal to 2 times the radius. That's why we know that the height, instead of putting h for the height, like this equation, when we collect the like terms, as we did in one of the earlier videos, 2 times 2 is 4, and the 3 is still there, the pi is still there. R squared times R cubed. And that is how we get the formula for the volume of a sphere. So if we have the radius, then we can easily calculate the volume. So now we have the formula, and let's say I say that the diameter of a sphere is 2290 kilometers, which means that the radius is 1145 kilometers. It's just half of that. And if I was to plug that in here, 4 over 3 pi times 1145 cubed, then yeah, you guessed it, it would be 6 billion 300 million kilometers cubed. If anyone's wondering why this is so big, that's because the diameter I gave you is actually the diameter of Pluto, the planet. Or is it a planet? I forget. I don't remember. Whatever it is, that space rock, its volume is 6.3 billion kilometers cubed. So yeah, if we want, we could also do it like backwards. Like say, let me just clear this up. So, if we were given the volume of something, say a volume of, let's say I was giving a volume of 100 meters cubed, and I wanted to find the radius of this sphere. It's the exact same thing. You just rearrange the formula to do 3 over 4 times 100. Well, 3 times 100 divided by 3 pi, and then do the cube root, and that's that. I'm not gonna plug it in because, or like solve it. I don't have my calculator near me, but I'm sure it's a real number. So yeah, that is all for this video on spheres. I shall see you in the next one.